So hi, this is Anirban Mukherjee and today I will be talking about Lod Score Analysis. So before starting, let's see what Lod Score stands for. It stands for Logarithm of Odds, and this method is devised by Newton E. Morton in 1955. It is just a statistical analysis to deal with small data sets, and it is used to analyze linkage of human genes. There is a formula to it of how to find out whether two genes are linked or not. This is done by analyzing a pedigree. So it is the logarithmic ratio of probability of linkage and probability of non-linkage. So the formula states that the Lod score equals to log of probability of linkage at x map units by probability of no linkage, where x is the recombination distance between two genes. Now, what does log score actually indicate? Log score indicates whether there is linkage between certain genes or not. Now, log score, when calculated, we can get a positive score or a negative score. Now, the positive score indicates that the linkage is present, and the negative score indicates that linkage is absent. Now, as it is a statistical analysis, there is a certain threshold, a certain score above which, when we get a log score above that certain threshold, we consider linkage being present. So the score is 3.0. If the score is more or equal to 3.0, we get a strong possibility of linkage. Now, what does score of 3 actually mean? It means that the possibility of linkage is 1000 and possibility of no linkage is 1. So there is 1 in 1000 chance that there will be no linkage, right? So the amount of linkage happening, or the chance of linkage happening, is pretty high. So a score of 2, similarly, it indicates that there is a chance of 1 no non-linkage happening in 100 conditions. Now, what does this 10 map unit distance actually mean? So it means that if there are two genes, that is A and B, the distance between them is 10 map units. Now it also means that if the distance between them is just 10 map units, it means that only 10% chance of recombination occurring is there. So only 10% recombinants will be formed and 90% parental type or non-recombinants will be formed, right? So chances of these two genes being inherited together is very, very high. So this is just what I've just said right now. And to put it simply, we can write that non-recombinance equals to linkage between two genes, which is equal to two genes being inherited together. And recombinance equals to non-linkage, which is equals to two genes not inherited together. We will be looking at a pedigree. So we can see that in the third generation, 6 offsprings are being produced, right? Now we can also see that the shaded ones are the ones having affected with a disease. Let's just name that as a syndrome X, and let's just say it's an autosomal disorder. Now, as you can see, with the individual with syndrome X and blood group AB, on mating with a normal individual with no disease, produces 6 offsprings. Now, if you analyze or look at this pedigree closely, you will find that the syndrome X, or the diseased ones, are the individuals having A alleles within them, right? So here all offsprings individuals with A allele is affected by the syndrome X. We can see that apparently by looking at the pedigree. And also we can see that the parental type is the one where we have syndrome X and the allele A together in one individual. That is the parental type. Now on closer look, we'll find that there is one offspring or one individual where the allele A is present, but there is no disease phenotype, right? So there is no presence of syndrome X. So we can say that this is a recombinant or a non-parental type. Let's go into the Lod score analysis. Here we have already stated that only one offspring is found recombinant with respect to the fact that AO blood group and the syndrome X are not present together in one individual. So the frequency of that recombinant being present is 1 by 6. Why 1 by 6? Because there are 6 offsprings are present, right? So only one among them is recombinant, so we are getting 0.167. So then we can also calculate the frequency of the non-recombinants or the parental types. That is by simply subtracting 1. If we subtract 0.67 from 1, we can get 0.833 as the frequency of parental type. Now, as there are two parental types, that is AB and OO, so we'll divide this frequency by 2 and get 0.4165. Next, we will look at the probability of linkage. So the probability of linkage occurring is we will take 0.4165 to the power 5 because there are 5 offsprings which have parental combination, and 0.167 to the power 1 because only one having the recombinant type. So we'll get a number, right? For probability of non-linkage, there is a trick to it. If two genes are, let's say that if the two genes are unlinked, then there will be 50% chance of recombination. So the recombination frequency would have been 0.5. So if the recombination frequency is 0.5, then the probability of any given genotype to occur in the offspring is 0.5 into 0.5, right? So there is a chance of 0.5. So half of the alleles, half of the genes which are present in this individual will come to this offspring, and half from this individual will come to this offspring. So 0.5 from this parent and 0.5 from this parent will give 0.25 to each offspring, right? So probability of non-linkage will be then 1 by 4, and as there are 6 offsprings, so 1 by 4 raised to the power 6 will get a certain number. And next we will put these two numbers within a certain formula, that is Lod score equals to log of probability of linkage and probability of non-linkage. Then it gives 0.933. So if the score is less than 3, as we have already stated that there is a threshold score, if the score is less than 3, then we can state that there is very low chance of linkage or no linkage at all, right? So this was about the calculation of Lod score analysis. So if you have any questions regarding this, please feel free to comment below, and thank you.